We'll start in about a minute. We'll continue the test 2 review. Tomorrow is the test 2. So you can join the Zoom meeting at about 7:45. I'll have to schedule it to start at 7:30 a.m., but I won't let you take the test earlier than 7:45. And so join the Zoom meeting. I'll send the information about that later today. Okay, we got to this problem down here yesterday, factor the polynomials. This one on the left is a difference of squares. You can rewrite it as the term 9c squared minus the term 8k squared. And then factor a difference of squares. One factor is 9c minus 8k. The other factor is 9c plus 8k. This one over here on the right is a sum of squares. And in this course, we don't factor a sum of squares. We have to use numbers that are not real numbers in order to factor it. So for now, we just say not factorable. It really is factorable, just not with real numbers. Okay, on the next page, we have a few more polynomials to factor. The one on the upper left, 27x to the third minus 8y to the third. This is a difference of cubes. We can rewrite it. 27x to the third is the same as the term 3x to the third. And 8y to the third is the same as the term 2y to the third. So we can see more clearly that it's a difference of cubes, and then just apply the factoring formula. The binomial is 3x minus 2y. And then the trinomial, we square 3x to get 9x to the second. And then we add 3x times 2y, which is 6xy. And then we add the square of 2y, which is 4y to the second. So this is the factorization for the difference of cubes. Over here on the right, we have a sum of cubes. Let's rewrite this. 64m to the third is the same as raising the term 4m to the third. And 125n to the third is the same as raising the term 5n to the third. So we have a sum of cubes. Then just use the sum of cubes factoring formula. The binomial is 4m plus 5n. And then the trinomial, the first term in the trinomial is what we get when we square 4m. That's 16m to the second. And then we subtract 4m times 5n, and that's minus 20mn. And then finally, The third term is plus what we get when we square 5n, so plus 25n to the second. So if you're, as usual, if you're ever in doubt about your factoring, you can always check it by multiplying. Okay, this next one, 81u to the second plus 144uv plus 64v to the second. The greatest common factor of all of the terms is 1. And so you might wonder if it is a perfect square trinomial because the term on the left is a perfect square and the term on the right is a perfect square. Okay, so if it is a perfect square trinomial, then it has to have a certain form. So instead of 81u to the second, I'll write the term 9u to the second, and 64v to the second is equivalent to the term 8v to the second. So if this is a perfect square trinomial, the middle term has to be equal to plus 2 times 9u times 8v. And when you do the arithmetic, 2 times 9u times 8v is the same as 144uv. So it has the right form. That means it is a perfect square trinomial. And so the two factors are 9u plus 8v times 9u plus 8v. Okay, this next polynomial, 3x squared minus 48x plus 189. This has a greatest common factor of 3. So factor that out first. We get 3 times x to the second minus 16x plus 63. And then we'll check to see if we can also factor x squared minus 16x plus 63. So let's use the AC method to see if we can factor it using integer coefficients. So we're just focusing on x squared minus 16x plus 63. 1 times 63 is 63. We want to see if we can find two integers that have a product of 63 and a sum of negative 16. So we'll use the exhaustive systematic approach. If two numbers have a product that's positive and a sum that's negative, then they both must be negative. So we start out at the extremes, negative 1 times negative 63. Negative 2 is not a factor, but negative 3 times negative 21. Those add up to negative 24, so we're getting closer. Negative 4 is not a factor. Negative 5 is not a factor. Negative 6 is not a factor. But negative 7 is. Negative 7 times negative 9. Those add up to negative 16. So that means we can factor further. So down here, I'll just rewrite x squared minus 16x plus 63 into a quadrinomial. X squared minus 7x minus 9x plus 63. And then we'll factor by grouping. Out of the first two terms, we can factor out x. So we get x times x minus 7. The middle operator is subtraction. That reminds us to factor the negative of the greatest common factor out of the third and fourth terms. So out of the third and fourth terms, the greatest common factor is 9, so we're going to factor out negative 9. And we get negative 9 times the binomial x minus 7. And then x minus 7 times x minus 9. So the complete factorization of our original polynomial has to include the factor 3. So we write 3 times these two binomials, x minus 7 and x minus 9. All right, the next example, x squared plus 7x plus 9. The greatest common factor is 1, so let's try the AC method. 1 times 9 is 9. Try to find two integers that have a product of 9 and a sum of 7. So if two such integers exist, they both must be positive. Okay, so 1 times 9, that's the first pair. They add up to 10. The next pair is 3 times 3, but they add up to 6. And there's no other pair to test. So even though this is factorable, it cannot be factored with integer coefficients. So we just say not factorable to tell a little bit more of the complete story. We say not factorable with integer coefficients, even though it is factorable. Okay, you can take college algebra to learn how to factor that. The next one, we have a quadrinomial. So when we see a quadrinomial, we want to try factoring by grouping. Even though factoring by grouping doesn't always work, we'll check to see if it works in this case. So out of the first two terms, factor out the greatest common factor, which is 15 times p. And then after we factor that out, we have a binomial q minus 1. Bring down the middle operator of addition. And then out of the first two terms, out of the third and fourth terms, the greatest common factor is 12. And factor that out, we get a 12 times q minus 1. And then q minus 1 times 15p plus 12. This is not the complete factorization because I failed at the start to factor out the greatest common factor. But even when we get to this stage, we can correct this. The greatest common factor of 15p and 12 is 3. So when we factor 3 out, the binomial is 5p plus 4. Hey, the numerical coefficients usually under conventional terms, we usually put that farther to the left and then write the algebraic fractions afterwards. Okay, now we solve equations by factoring. So you have no doubt figured out that one reason that we want to learn how to factor polynomials is so that we can apply that when solving equations, which we often try to solve by factoring. So on this one, solve by factoring, one side is already 0 and the other side is already factored. So to find the solutions, we just set each factor equal to 0 and then solve those simpler equations. If n plus 9 is 0, then n is negative 9. And if n minus 2 is 0, n is equal to 2. So the two solutions to that equation are negative 9 and 2. Okay, this next one, 5x squared minus 35x equals 0. The right-hand side is already 0, and now we just have to factor the left-hand side. The greatest common factor is 5x. And after factoring 5x out, we're left with x minus 7. And then we set the factors equal to 0. Set 5x equal to 0 and x minus 7 equal to 0. And on this one, 5 times x equals 0, divide both sides by 5. X equals 0 divided by 5, but that's just 0. On the other one, x minus 7 is 0, add 7 to both sides, and we get x equals 7 for the second solution. Yeah, the next one, x squared minus 9x equals negative 18. If we're going to solve by factoring, we want one side to be 0. So we'll add 18 to both sides. We get x squared minus 9x plus 18 equals 0. And now we want to factor the left-hand side. We can use the AC method. 1 times 18 is 18. Two integers that have a product of positive 18 and a sum of negative 9, or negative 3 and negative 6. So do you remember the abbreviated AC method that I described a couple of times? When you have a quadratic equation in standard form, that means one side is 0. And if the coefficient of x squared is 1, and if by using the AC method you find the two integers that satisfy the two conditions, so in other words, negative 3 and negative 6 have a product of 18 and a sum of negative 9, then you can bypass the transformation into a quadrinomial and write down the factors directly. Okay, but this only works when the coefficient of x squared is 1. So one of the numbers is negative 3, so we write the factor x minus 3. The other number is negative 6, so we write down the factor x minus 6. And if you're ever in doubt, you can multiply the factors to verify that you have the correct factors or not. Okay, but now that the left-hand side is factored, we set each factor equal to 0. X minus 3 is 0, and x minus 6 is 0. And the two solutions are x equals 3 and x equals 6. Okay, the next equation, y to the second minus 14y plus 49 equals 0. This trinomial is a perfect square trinomial. The two factors are identical, y minus 7 times y minus 7. Hey, the two factors are identical, so there's one solution, 7, with multiplicity 2. So y equals 7 with multiplicity 2. So 2 is equivalent to the number of identical factors. All right, the next page, solve a few more equations by factoring. (25x squared equals 16). In a few days, we'll learn how to factor, or we'll learn how to solve this particular equation using a different method. But for now, we'll solve it by factoring. So that means we're going to make one side equal to 0. And we can do that if we subtract 16 from both sides. And now we'll try to factor the left-hand side. So in the event that I've almost put you to sleep, I'll wake you up. If you're watching online, you can probably type in the factors of 25x squared minus 16. Or if you're in the classroom, you can probably just tell me, what are the factors of 25x squared minus 16? It involves 4 and 5. Yeah, what are we looking at? What kind of polynomial is 25x squared minus 16? It's a difference of two squares. 25x squared is a perfect square. If we square the term 5x, we get 25x squared. And 16 is 4 squared. So one of the factoring formulas that you should make sure you're well acquainted with is the difference of squares factoring formula. So I'll write it up here. A to the second minus b to the second. The two factors are a minus b times a plus b. So that's what we'll apply here. We have a difference meaning subtraction of two squares. So one of the factors is 5x minus 4. The other factor is 5x plus 4. And then set each factor equal to 0 and solve for x. So 5x minus 4 is 0, and 5x plus 4 is 0. So the one on the left, add 4 and divide by 5, we get x equals positive 4/5 for one of the solutions. And the other equation, subtract 4 and divide by 5, the other solution is x equals negative 4/5. Here, the next equation, 14y to the second minus 77y equals negative 35. First, add 35 to both sides so that one side is 0. So we get 14y to the second minus 77y plus 35 equals 0. Now we want to factor the left-hand side. So the first step in factoring, identify the greatest common factor of all of the terms. 7 is a common factor, and it turns out that 7 is the greatest common factor. So I'll say something that I hope won't be confusing. When we're solving equations, there's something we can do that we cannot do if we're just factoring a a polynomial that's not an equation. So an equation always has an equal sign. So when we're solving an equation, we are permitted to divide every term on both sides of the equation by the same non-zero number. If all I was doing was factoring a trinomial that's not an equation, I can factor out the greatest common factor, but I can't divide it out. I have to, if I'm just factoring a polynomial that's not an equation, then I must include the greatest common factor in the factorization. But if I'm solving a polynomial equation, I can divide every term on both sides by the same non-zero number. And since the greatest common factor is 7, I can divide every term on both sides by 7. So when I divide every term on both sides by 7, I'm going to get 2y to the second minus 11y plus 5. 0 divided by 7 is 0. Okay, so the idea is the solutions to each of those two equations are exactly the same, but this bottom equation is a little bit easier to look at because the numbers are not as big. See what I mean? So let's factor this trinomial, 2y to the second minus 11y plus 5. We could use the AC method. So 2 times 5 is 10. Two integers that have a product of positive 10 and a sum of negative 11 are negative 1 and negative 10. The product is positive 10 and the sum is negative 11. Okay, so let's write this 2y to the second minus y minus 10y plus 5 equals 0. And then factor by grouping. Out of the first two terms, factor out y. The binomial is 2y minus 1. The middle operator is subtraction. So out of the third and fourth terms, we're going to factor out negative 5. And the binomial is 2y minus 1. And then finally, 2y minus 1 times y minus 5 equals 0. Okay, so up here I'll set each of those factors equal to 0. 2y minus 1 is 0, and y minus 5 is 0. So solve for y. We, on the top equation, add 1 and divide by 2. We get y equals 1/2 for one of the solutions. And for the other solution, add 5 to both sides. We get y equals 5. Okay, let's do the next couple of equations. 4a to the second plus 7a equals negative 3. So add 3 to both sides. We get 4a to the second plus 7a plus 3 equals 0. Okay, so to factor 4a to the second plus 7a plus 3, let's try the AC method. 4 times 3 is 12. We'll see if we can find two integers that have a product of 12 and a sum of 7. So we'll start at the extremes. 1 times 12, those add up to 13. 2 times 6 is 12, but those add up to 7. 3 times 4, 2 plus 6 add up to 8. And then 4 times 3 is 12, and 4 plus 3 is 7. So 4 and 3 are the integers we're looking for. So we rewrite this as 4a to the second plus 3a plus 4a plus 3 equals 0. And then factor by grouping. Out of the first two terms, factor out a, and the binomial is 4a plus 3. Bring down the middle operator of addition. Out of the third and fourth terms, we can factor out 1. So 1 times the binomial 4a plus 3. And the factors are a plus 1 and 4a plus 3. So we set a plus 1 equal to 0, and we'll get a equals -1 as a solution. Set the other factor, 4a plus 3 equal to 0, so we subtract 3 and divide by 4. The other solution is a equals -3/4. So those are the two solutions. Okay, the next one, m to the third minus 2m to the second equals -m. So we'll add m to both sides to get m to the third minus 2m to the second plus m equals 0. The greatest common factor is m, so we factor out m, and we get m times m to the second minus 2m plus 1. M to the second minus 2m plus 1 is a perfect square trinomial. So its two factors are m minus 1 times m minus 1. And this equation has m equals 0 as one of the solutions. The other two factors are identical, so m equals 1 is the other solution, but m equals 1 has multiplicity 2. There's only two solutions, 0 and 1, but m equals 1 has a multiplicity of 2. Okay, let's look at some word problems. Number 10, part A, the product of two consecutive odd integers is 255. Two consecutive odd integers differ by 2. So we can say, we can represent them by x and x plus 2. And if the product is 255, that means when we multiply x times x plus 2, we get 255. And this is just a quadratic equation. X squared plus 2x equals 255. We'll try to solve it by factoring, so we'll subtract 255 from both sides. We get x squared plus 2x minus 255 equals 0. Okay, we can try the AC method. 1 times negative 255 is equal to negative 255. And we'll try to find two integers that have a product of negative 255 and a sum of positive 2. Okay, so if two such integers exist, the one that's with the largest absolute value is positive. So at the extremes, if we do the systematic approach, negative 1 times positive 255. Negative 2 is not a factor, but negative 3 times 85. Negative 4 is not a factor. Negative 5 times 51. Negative 6 is not a factor. Negative 7 is not. Negative 8 is not. Negative 9 is not. Negative 10. Negative 11. Negative 12, no. Negative 13. So finally, up at negative 17, we get a factor. So negative 17 times positive 15. No, that's not right. So what I should have written was negative 15 times positive 17. Yeah, so those are the two integers we want, negative 15 and 17. So remember the abbreviated AC method? If the coefficient is 1 and we find the two integers, one of the integers is negative 15, so we can write x minus 15. And the other one is positive 17, so we can write x plus 17. And then set each one of those equal to 0. X minus 15 equals 0 equals x, means x equals 15 is a solution. Set x plus 17 equal to 0, we get x equals negative 17. So this problem has two sets of answers. When x is 15, x plus 2 is 17. But the other pair of solutions also works. If x is negative 17, then negative 17 plus 2 is negative 15. So that is the second pair of consecutive odd integers that have the product of 255. Okay, the next problem, similar. This one says the product of two consecutive even integers is 224. Two consecutive even integers differ by 2, so we can represent those as x and x plus 2. And then the product, x times x plus 2, is 224. So x squared plus 2x equals 224. Then set one side equal to 0. We get x squared plus 2x minus 224, 0. Okay, so we'll try the AC method again. 1 times negative 224 is negative 224. Find two integers that have a product of negative 224 and a sum of positive 2. So similar to what we did earlier, one must be positive, one must be negative, but the one with the largest absolute value is positive. So at the extremes, negative 1 times 224, then negative 2 times 112. Negative 3 is not a factor, but negative 4 times 56 is a factor. Negative 5, no. Negative 6, no. Negative 7. And 32. Those add up to 25. Negative 8 times 28. Negative 9 is not a factor. Negative 10, negative 11, negative 12, negative 13, negative 14, and 16. So those are the two integers, negative 14 and 16. Since the coefficient of x squared is 1, we can use the abbreviated AC method. One of the integers is negative 14. So one of the factors is x minus 14. The other integer is 16, so the factor is x plus 16. And once again, we get two sets of solutions. If x minus 14 is 0, then x is 14, and x plus 2 is 16. The other set of solutions, if x plus 16 is 0, x is equal to negative 16, and x plus 2 is negative 14. So once again, two sets of consecutive even integers that have the same product of 224. Okay, I'll just write down how to set up this next one, and then we'll look at some other word problems. The product of two consecutive integers is 240. So two consecutive integers differ by 1, so x and x plus 1 is how you can represent them. And then the product is x times x plus 1 equals 240. And then just solve this equation, x squared plus x, and then minus 240 equals 0. Solve this for x. Here on the last page of the test review sheet, we have some more word problems. The one on the top, the area of a rectangle is 28 square feet. The length is 5 feet less than 3 times the width. Find the length and width. So notice that the length is described in terms of the width. So if I assign a single variable to the width, like x, feet, and then the length is described in terms of x. The length is 5 feet less than 3 times the width. So 3 times the width is 3x, and 5 less than that is 3x minus 5. And then the area of a rectangle is length times width, which is given to be 28. So if we multiply length, 3x minus 5 times width, we get 28. So what we have is a quadratic equation. So you can set one side equal to 0, 3x squared minus 5x minus 28 equals 0. And then you can use the AC method to solve for x. So I'll leave the rest of that for you to do. Use the AC method to factor. So hopefully you're getting pretty good at the AC method. But the next problem, let's set this one up. Part E, a right triangle has a hypotenuse of 10 feet. The length of one leg of the right triangle is 2 feet longer than the other leg. Find the length of each of the two legs. So if you want to draw a triangle, a right triangle, that might help. The hypotenuse has a length of 10 feet. And the length of one leg of the right triangle is 2 feet longer than the other leg. So if I use x for the shorter leg, and the other leg is 2 feet longer, I get x plus 2. And then we apply the Pythagorean theorem. So apply the Pythagorean theorem. So that says if we square the hypotenuse, 10 squared, that's equal to the sum of the squares of the lengths of the two legs. So x squared plus the binomial x plus 2 squared. Okay, what we have is a quadratic equation. So get it into standard form. When you square x plus 2, you're going to get x squared plus 4x plus 2. And then 100 equals 2x squared plus 4x plus 2. Then we subtract 100 from both sides. And I'll write it as 2x squared plus 4x minus 98 equals 0. We can get some of the clutter that we don't need out of the way. We can divide every term on both sides by positive 2, since it's an equation. And we get this equation if we divide every term on both sides by 2, x squared plus 2x minus 49 equals 0. Okay, so I'll leave the rest of that for you to do. Let's look at the next problem. The length of a rectangle is twice as long as the width, and the area is 288 square feet. Find the length and the width. So if I pick, since the length is described in terms of the width, I'll pick x to represent the width, and the length is twice as long as the width, so it's 2x feet. And then the area is 288 square feet, so for a rectangle, to find the area, you multiply length times width. So we just have 2x squared equals 288. We can divide both sides by 2, and we get x squared equals 144. Set one side equal to 0, x squared minus 144. 144 is a perfect square, so 12 squared is 144. So the two factors are x minus 12 and x plus 12. We're only going to get one positive solution, positive 12. The negative 12 solution doesn't make sense in this problem, so the width of the rectangle is 12 feet, and the length is 24 feet, 2 times x. And the width is 12 feet. Okay, we have a little bit more than 2 minutes left. Let's see if we can set up this problem, part G. From the top of a building that is 80 feet above the ground, a projectile was launched upwards. The height h in feet of the projectile above the ground, t seconds after being thrown, is modeled by the equation. The height is negative 16 t to the second plus 64 times t plus 80. So t represents the number of seconds. H represents the height of the projectile. So find the number of seconds it takes for the projectile to reach 144 feet. So to solve part 1, you replace h with 144. So we get 144 equals negative 16t to the second plus 64t plus 80. So I'll do a little bit more on this one. we'll make one side equal to 0. So I'm going to add 16t to the second to both sides. And I'm going to subtract 64t. And subtract 80 from both sides. So 144 minus 80 is 64, and the right-hand side is 0. And then note that we can divide every term on both sides by 16, because 16 is a common factor. Divide every term on both sides by 16, we get t to the second minus 4t plus 4. This factors really nicely. It's a perfect square trinomial. The two factors are t minus 2 times t minus 2. So this only has one solution, so it means that it takes 2 seconds for the projectile to reach 144 feet. And then in part 2, find the number of seconds it takes for the ball to hit the ground. So when the ball hits the ground, the value of h is 0. So you just replace h with 0 and then solve this equation. 0 equals negative 16 t to the second plus 64t plus 80. I'll just say one more thing. Divide every term on both sides by negative 16. And that will make solving it a little bit easier. Okay, that's all we have time for today. Remember tomorrow to join the Zoom meeting at about 7:45 a.m. And when you join the Zoom meeting, I'll email you the test. So that's all for today.